So, today's lesson, and I believe we'll be able to get through all of it, is covers points, lines, and planes. The second part of it is linear measure. We will definitely get through the points, lines, and planes. But after today's lesson, you should be able to identify and model collinear and coplanar points. That's coplanar, not complanar. Coplanar means they're all on the same plane. Complanar is points that just line along. Yeah. All right. Anyway, the second part we will measure and compute with measurements. Like I said, I don't think we're going to get to that second bullet point today. All right. Anyway, starting off, a point is simply a location. It is drawn as a location, and that location is denoted with a point, and it is named by a capital letter. In this case, we will call it point P. And that is how it is written. Easy enough, right? By the way, if I write it on my board, you should write it in your packet. That's why I gave you the packet. Moving on. A line is made up of points and extends infinitely in each direction. What does it mean to extend infinitely in each direction? Good, right? It goes on forever. All right. And it is named by two letters representing 2 points or a lowercase script letter. So, for example, we could call this line AB. We could also call it line A. If I put a script A there, we can also call it line A. Either way. We will use this notation somewhat frequently, just because many diagrams have many points on them and multiple lines, and it is easier to call it by a single script letter than it is by figuring out which two, when you have these 2 points, that line, that kind of thing. All right. We do this for you guys, and actually for me too. It's easier on me. All right. So far, we're talking points and we're talking lines, and I think that's pretty straightforward. When we get into planes, I think this is a little different for most folks. What a plane is it is a flat surface. Okay, so this Promethean board could be a plane. This desktop right here could be a plane. All right, the floor is a plane. The ceiling is a plane. This whole front wall could be thought of as a plane. Yes? All right, sweet. It is drawn as a shaded, slanted four-side figure. I'm not going to shade mine, but typically it kind of looks like a parallelogram. It is named by an uppercase script letter. So we could name this plane T. Also, you only need 3 letters to or 3 points to denote an actual plane. So 5xyz, I have the point x, I have the point y, and I have the point z. I can call this T, or I can call that plane T, or I can call this plane X, Y, Z. Either way. Can I move on? All right, moving on. All right. Points that are on the same line are said to be collinear. That's how you say that, collinear. Similarly, points that lie on the same plane are said to be coplanar. Right? All right. Let's go through these examples. A dartboard is an example of what, Logan? A plane. Very good. Hunter, the end of a dart is an example of a Hunter, think for a second. I throw a dart, it comes in, it does that. What's that? Yeah, but a dot is in something that we went over. We have points, lines, and points. A point. I know you're using the really technical term dot, but let's stick with point. Okay. All right. A stretched piece of yarn. What's that going to be, Michaela? A line. Very good. All right. The feet of a stool are examples of what, Violet? Points. Very good. Earlier today, we had a little bit of confusion on that. But when we're talking about the feet of a stool, if I have this stool right here, and I dipped it in paint, and then took it over here and put it on the floor, I would run and hide this and kill me. But when I picked it up, I would have 4 points on the floor, right? Yep. All right. And lastly, a piece of paper is an example of what, Abigail? Like, very good. Okay, you guys don't have that in your packet, do you? All right, we're gonna keep rocking that. All right, you have this one? Okay, so what we have here is, it says draw the segment and determine each measurement. First off, please bear with me. You might want to draw the points J, K, and L on. Yes? Now, whenever we're solving problems like this, and we are going to, I will tell you right now, we're starting what's called segment addition. All right. But what we do here now with segment addition, in a couple weeks, we are going to do a similar thing with angles. It's going to be angle addition. Right? And then we'll spend probably a couple months on segment and angle addition. And then probably somewhere around November, we will actually get around to doing angles in triangles. And we're going to use angle addition within the parameters of a triangle. Right? And then we're going to figure out exterior angles. Then after that, then we're going to do angle addition in the parameters of a quadrilateral. We are also going to do segment addition in the parameters of a quadrilateral. The point of it is, the stuff that we are covering right now today on our last lesson of the school year we will still be dealing. Some of you, you're going to get it like that, and you're going to say, wow, this is easy, this is no problem. Others of you are going to be like, what? We'll get it eventually. All right? But there are 4 basic strategies that we are going to deal with. And what they are the first strategy is the 4 strategies. And you guys should write these down, write this in your notes. Number 1, part plus part equals whole. Now that should not seem that radical to you. That should take you back to basically what, 1st grade kindergarten? Only we're going to be making it a little more interesting. Part plus part equals whole. The second strategy is part equals part. The third one is whole equals part minus part. And lastly, we will have whole equals whole. And when we first start off, we're basically going to choose one of these strategies, and that's going to be enough to solve the problem. Later on, we will get more complicated where we have to use multiple. We're going to start off with one strategy, figure out something, and then we're going to stick it into another strategy. And maybe use the third or the strategy. All right. But the point of it is the strategies themselves are relatively simple. The other thing is it is going to be very important when you're solving problems to follow the problem-solving steps up here. And of course, the first thing that you should do is always read the problem. The second thing that you should do is you should think. Before you cry, take a deep breath and think. Yes? And lastly, we are going to act. Now, when we act, there are some steps that we're going to take. And really the focus on what we're going to do right now is going to be on these actions that we have up